Hello everyone, December 18th. Max chunks to make sorted. We'll give an integer array, length n, that represents a permutation of the integers in the range 0 to n minus 1. We split array into some number of chunks and individually sort each chunk. After concatenating them, the result should equal the sorted array. Return the largest number of chunks we can make to sort the array. So basically what we want to do is split them up into chunks or partitions, sort them, concatenate them, and make it into a sorted array. So in this case, it's not possible, right? Because these are the front. Because when you chunk it, right, you have to make sure that, like say 1 is in the first, or like 0 is in the first chunk, right? So you basically go look for 0. Once you find the 0, and yeah, like we need to find 0. Like the first chunk must include, let's say, the first k must include 0 to k minus 1, right? So in this case, we can have, this is one chunk, and we can have individual chunks, so it's 4, right? N is 10. So, okay, so what I think is, right, you go, A0, A1, A2, all the way to AN minus 1, right? So what you want to find, so like we start with 0. So you go, find the first one that contains 0, right? Yeah, we want to find what is the first chunk, right? The first chunk should be, the first chunk should be the subarray that contains from 0. Yeah, so the first chunk, let's say if the length is k, then it should include 0 to k minus 1. That's what the first chunk should be. So I keep going, and we find 0, right? But that does not equal to the first chunk if it doesn't contain everything, right? So I need to keep going, right? We have found, like, the first target is 0. Once we found 0, we need to check, like, which number is missing. So we need to find the next smallest that is missing, right? So we have whatever, and we can say what's the next. Yeah, we can say what's the next. Priority queue, right? So we have 0. So basically we keep going, and then we put everything to a min heap, and now we hit, because the target is 0, right? So we hit 0, okay, which is good. And then what we need to find is, when we hit the target, the next one should be 1. So we pop on the heap to see if a 1 is in there. If it's in, next one is 2. Right, we just keep going until one of them is not there. Right, if one of them is not there, so this is our target. Let's say 3 is not there. So we have to keep searching, right? Keep searching to find 3. Once 3 is there, then we keep popping. So once a chunk is ready, it's when I have the entire, I pop everything. Right, I pop everything and that the chunk is ready. Right, now we go for, now that when the chunk is ready, I also know what is the next target, right? So we find the next target and the priority queue is empty, then that is what we'll put in. Okay, let's give this a shot. So basically we need to do priority queue int vector of int greater all right, so that's the start, and result is here. Now we're just gonna go one by one, and the target we should be 0. And for int I 0. It doesn't really matter, right? Maybe I can just go this. If A is not equal to target, then pq dot push A. Else A is equal to target, right? If current A is equal to target, then we need to, then that's good. Hold on. You know what? I think I shall say pq dot push A first. Okay, we put it in. And then if, right, we push A. And while it's equal, so while pq dot empty and pq dot top, right, is equal to target. Okay, so that's true. Then pq dot pop and then target plus plus. Right, so if the top is equal, then I'll pop. Right, and the next one, target, next one, next one, next one, next one, until the end. We get out. Right, so when we get out, we say if pq dot empty, then rest plus plus. Right, otherwise if pq is not empty, then we keep going. Right, we keep going, and at the end we'll return rest. Okay, let's give this a shot, see how it goes. Okay, looks good. Let's put some comments up. 769. Use priority queue, use a min heap to keep track of the minimum value encountered so far. We also use a target to keep track of what we need to include, track of the minimum value we must include in the current chunk, right? If the min of if min heap, right, if the main heap and the target and the target matches, right? We search for the next min, right? Once the main heap is exhausted and all the targets can be satisfied, we have found the smallest chunk so far. Right. Then we move on for the next smallest chunk. So we have to go through O n, and each one I think it's O n log n. I mean, we do have the pop, and the most I pop I don't know how many times, because I'll add something, right, and then we'll pop. And add something more, then we pop. I can say we pop n times, so we can say O(n) squared log n, right? Because you do this n time, each time you can the most pop n times. Alright, so maybe this is the runtime. I have no idea. That's how it feels to me. I think I want to run a few more test cases. For example, we can do that's actually interesting. Okay, throw a few more. Oh, looks about right. Okay, let's go for it. Oh, it's not very hard, but there's also a hard problem for this, so I bet that one is harder. Oh, I think I know what this one might be. Exact same, but just 10 to the 5th, 2000. Oh. Is that exactly the same problem, right? Oh, it's not necessarily that you can repeat, it can be anything. It's an interesting problem. Interesting problem. Maybe we can use the same method, but we'll see. Prefix max and suffix min array. Prefix sum. Monotonic increasing. Maximum element. Well, apparently my method is not good. Alright, so what's this? Prefix max and suffix min. So we go prefix max, fill in the suffix min. Then we go through everything. If suffix min is the minimum, right? If suffix min is larger than prefix max, ooh, that is good. That is good. Yep, it is suffix min and prefix max. Yeah, so every time that the suffix min is larger than the prefix max, that basically means the prefix contains everything that's smaller than even the smallest on the suffix. So yeah, then you form a chunk. Then you form a chunk. I am not sure about this. I think I'll do it differently. Because the ways you go is you have the suffix min here. So I would say I and I plus 1, right? And if that's good, then you have it. And then go. Suffix min. It's bigger than prefix max, And then if suffix min is not bigger, right? If it's not bigger, then when you go to the end, yeah, how would you handle this situation? Suffix min is just like this, prefix max. So if you start from here and here, that is a no-go, right? That is a no-go, and then we get out. The get out becomes 0. So do we just call it 1 if it's 0? Okay, suffix min, in this case, suffix min here is 0, right? And there's a 1, so that's a no-go. Move on to here, suffix min is 2, prefix max is 1. So this is a go, right? This is a go. So I say 1 is at here, I do 1. Ending at this, I do 1. And then going here, suffix min, prefix max. So that's another one, 2, 3, right? And now I come to this part. It doesn't have any suffix. So what I can do is, like, I can put an extra stuff here, right? It's just like you go to the last one. What we want to ask is any chunk ending at the last one, right? Any chunk ending at the last one. So if we have something really big, right? Then the last one, yeah, because the last one you have to form a chunk no matter what. Yeah, so you just plus 1. So basically, so solution 1. Solution 2. So this is from the official solution, where we compare prefix max and suffix min, right? If suffix min is larger than prefix max, then we can create a chunk, right? So prefix max, I can just build it up. So we just need a suffix min. So we say std vector, right, int suff min. Okay, and then we say I can say suff min array.begin, array.end, right? Say for int I equal to array.size -1, I large equal to 0, I minus. That's actually not true because I want to do this. Right, and I can say suff min I shall equal to std minimum suff min I plus 1 and array I. Okay, so that's how we get suffix min. Now we have suffix min. Next should be res equal to 0 for int I equal to 1. I can actually just start it with 1 because you're always gonna have 1. So you can say I equal to 1, I smaller than array.size plus, and then we can have pref max array 0, right? This is the prefix max. So pref max equal to std max prefix max and array I, right? So if prefix max is smaller than suff min I plus 1, ooh, wait, hold a second. Oh, I can start from 0. Yep, I can start, actually I should start from 0, and then this one shall be -1, right? And I can say this is 0, and then get a prefix max, yes, and then if it's smaller than suffix min, res plus, right? And then we move on. And then at the end, because I end at 1 before, right? Yeah, I can actually just do this, and then we can say return res plus 1. We can say always include the chunk that ends with the last number. Yeah, I feel like this shall be right. I wonder if we can use this to solve the other problem. Sorted. I'm not sure. We're just trying. Nope. Maybe we do this. Borrowed from the solution of 768, 769. You wanna try? Yep, that is a solution. That is a solution. Nothing much to see. Just need to change it a little bit. Like in this one, I can do small equal to as well. Okay, so that's one. Prefix sum, interesting. Prefix sum. Oh, because you know. Ah, good. I think I know how the prefix sum will play in this, so we're gonna try it. But this will not work in the other one. Actually, will work in the other one as well. All right, so let's say this is the prefix sum solution from the official. Actually, we can try it in the other one as well. All right, we can try it in this one as well. All right, so the ideal is I have sum, right? Target sum, okay? We have target sum, and then we have a prefix sum. Pref sum, right? We have target sum and a prefix sum. Pref sum. And the goal is, as I go through array, when prefix sum is equal to target sum, that's a chunk. Okay, that's a chunk. We say for int a of array, ooh, that's not right. I need index. It's fine. We need index for this. All right. And then we say target sum plus equal to I, prefix sum plus equal to array I, right? If target sum is equal to prefix sum, then where's my res? Okay, if that's the case, then res plus plus, and at the end return res. Wow, this one's so much easier. All right, let's see if it works. Yep, looks solid. Good. So now we will try here. All right, so I'll copy this. Oh, it's the same signature. Wait, hold on, is this same signature? Yeah, same signature. Okay, we sort array first and produce, and from that we can produce the target prefix sum. Right? We know like at this position what it needs to be, and then then we produce the prefix sum of the original array, right? Wherever the two prefix sums are equal, we have a chunk. So this one requires array dot, oh, I think it's td. Actually, I don't know. How do I sort array again? Sort vector. It's in place, right? Yeah, I think it's in place. So we're gonna say sort start. Okay. And then target sum plus equal to, oh, You need a new one. I need a new vector for this. Sorted array. Alright. Let's say array.start, array.end. Okay. And then this is gonna be sorted array. Sorted array. And then this shall be sorted array I. Okay, let's try this. Oh, shoot. Let's begin, not start. I'm supposed to have 2 test cases for this. Alright, try it. Ooh. Oh, wow. Oh, 10 to the 8th. Long should still work. Long should still work. Maybe long will just work as well. Don't even need long. Okay, let's try this. Yep. I think long is good enough. Yep, that's good. Alright. More. What's the next? Prefix sum. Monotonic increasing stack. Alright. So it's saying that monotonic increasing can work. Monotonic increasing can work. How? I was thinking about it, but I couldn't figure it out. Well, what you can do is as you go through, right, you can record the largest value that you encounter so far, right? Because you do monotonic increasing, so you have some value, so it will pop. So every time you pop, you record the largest value that you have encountered. And that largest value like if the largest value you encountered is equal to the number, like the number of the chunk, then we have a chunk. Does that make sense? Yeah, so like every time you pop, you get the biggest value out. So whenever the current index is equal to the biggest value, that is a chunk. And next one comes in. Then why do we need a stack? Or when the largest is equal, the smallest need also to be equal. Yeah, we basically say that the largest is equal to the length, the smallest is the smallest, and the total length. So we won't have any other. Everybody will be in this chunk, right? Okay, so that's one, and we'll keep moving on. Let's say we got a bigger value, right? And then we just keep the biggest and keep the smallest, right? We just do min max. I think a min max will work, right? I think a min max will work. So this is the min max solution, not read from the official solution, but inspired by thinking about monotonic increasing stack. Right? We basically keep a prefix min and max and prefix max. Right? If the prefix min is equal to 0 and prefix max is equal to the current index, we can guarantee that a chunk, right, has been formed. So we can say pref min, well, I don't know, pref min size, pref max 0, that's equal to 0. So for int I, 0I smaller than size I plus plus, if pref min, update pref min plus, so pref min cd min pref min array I pref max okay pref min, if prefix min is equal to 0 and prefix max is equal to I, right, then res plus plus, and I'll return res. Ooh, this is not right. Shoot. Oh, it is? Why it took so long? Oh, yeah, this is probably not right. But no, we're pending. We're not even judging it. I mean, it should be right. Yeah, it should be right. Okay, so can we apply this one in this scenario? Well, so in this scenario, if we keep the min, it's the same. We just need to sort it. Right? This is the prefix min, prefix max solution. We don't have to create a we do have to create a copy, unfortunately. So it's the same, but we don't use this. We say int pref min sorted array. Well, we probably, let's do this, n equal to array dot size. Okay, so it'll be n minus 1 plus 1. Okay, pref max 0. Okay, so we do this, we don't do this. We copy our thing here. So we'll say this. Right. We say prefix min, prefix max. If this is equal to sorted array 0, prefix max shall equal to sorted array I, then rest plus plus. Let's see if this one works. And yep, I think this one works as well. Lots of traffic, huh? Oh, they might be throttling. Yeah, they might be throttling me. Which is, you know, if that's the case, I'll take it. It's all right. You know, how much can they throttle, right? Oh man, this is not even right. Yeah, it has to be this. Okay. So prefix min is 1. So this is not correct. This is not correct. This is correct because prefix min is 0 and prefix max is equal. But we didn't considering this. Oof. It has to be unique. And this is not unique. Yep, it's not unique. Anyway, let me check this, make sure that we got it right. I can skip this. I'll just take a look again. Oh, I don't even need a prefix min. Well, you do need a prefix min. As long as we don't have a 0. Ooh. Oh, I keep track of the current max and current min. That's what it's been doing. It's the same thing. You have the current min, you have the current max, right? So as you go, and yeah, I produce that. Wait, hold on. This one is requiring me some thought. So basically, what we want to guarantee is in between the two, everybody in between is smaller than this, right? Which means if I go monotonically increasing, right? Once the smallest come, it will pop everybody. And once you pop everybody, right? Once you pop everybody, if we keep track of the current maximum, right? Or keep track of the current maximum, then if I have a bigger one, it will just keep adding, right? And then we have another smaller one coming in, right? And the smaller coming will pop all the previous max. So basically, this is to keep track the prefix max, right? This is the prefix max. So I have prefix max. I have prefix max, and every time a smaller value comes, we'll pop, right? And then we'll prefix max. Because when 0 comes in, it'll pop up everything. And then we have the current max, right? The 0 definitely forms a chunk, but we don't know how long it has to be, right? So if the current max is not I don't understand. If I have a very big number and then followed by 0, right? And then the big number will come in, and then 0 will pop. So now it'll be 0 and a big number, right? And then I have a small number, and that small number will pop. Right? Like how does this work? If I have, let's say, 2, 0, 1. Right, 2, 0, 1, the answer should be 1. Right? 2, 0, 1, the answer should be 1. But in this case, first I push 2. Right? Then 1, then 0 comes. So I say, I'll save 2 else, and then it will pop, so it becomes 0. Then I put 2 back. Right? This is the current stack. Now 1 comes. Right? I take 2 out. No, so I don't put 1, but I'll put 2. So is this answer 2? Huh? I don't think this answer is 2 though. I think this answer shall be 1. Yeah, the answer is 1. Oh, the 0 does not get pushed in. The 0 is not pushed in, so the smallest doesn't get put in. Huh? What is this logic? Basically, it's just a current max, right? Current max, current max, current max. And then something bigger comes in, and it got pushed in. Okay. And then if there's something smaller, right? If basically if there's something smaller, then we'll pop them, whatnot. But then we'll have the bigger value remaining, right? The bigger value will remain there. Basically, okay, yes. Basically is we have the prefix max, right? We have the prefix max, and then we suppose that all the smaller values has already been encountered. Then this prefix max should sit at the top of, it should sit in the monotonic increasing stack without being popped again, right? Without being popped again, because everybody else will be bigger than it, right? If it gets popped, then yeah, we'll get popped, and then we'll put it back. Pop, we'll put it back. Once this does not get popped anymore, then that is. So it is basically to look for the max value, the prefix max, such that is the smallest, right? It's smaller than everybody in the suffix. So in this case, I can just go, find prefix max. But prefix max. Okay, I see this point, Right, if the current value is smaller, I just ignore. Right, if current value is bigger, I keep. If current value is smaller, right, if current value is bigger, then I increment, right? And the current value is smaller, yeah, and then is this max element the same? Yeah, it's not. Yeah, the max value that can sit in the prefix, the monotonic increasing is the number. What's this one? We get a prefix max. This one's slightly different, as I checked for the prefix min as well. It says it does not need to check prefix min, because if the max is equal to, right, then we'll have everybody in already. Yes, we don't need a prefix min. We don't need it. We just need a max. Because I know at this position we must have a certain number, right? We must have a certain number, and once we get a certain number, because if we have anything bigger, then it will become new max. Okay, yeah. That's actually simpler. I wonder if these two methods can be used for the harder version. Not sure if you want to go with yeah, I'm not sure either. So this is essentially the same as solution 4, except that we don't have to keep track of prefix min. So basically just say this. We probably can do rest equal to 0 here. Prefix max. If prefix max is equal to I, then we do this. Oh, shouldn't be solution 5. No, they did not. So that's good. Yeah, I don't think I will do the monotonic increasing. We have all the other ones. Now I'm more interested in this. Maybe monotonic increasing can work, because it's based on the same principle, right? Monotonic increasing array is based on the same principle, and the principle is the number of chunks, right, at the end shall equal to the number of prefix max that is smaller or equal to the suffix min, right? Smaller or equal to the suffix min, that's correct. Which in this case, now we can use the prefix max and suffix min for this, but we can also say if it's a monotonic increasing array, then we're keeping the prefix max. So if I have something coming in, right, if it's larger than what the current one is, then I just add to it, right? If it's smaller, then I'll pop, but we'll keep the max. And if it's equal, I will also add it. So this has a prefix, I think. 768. 768. Yeah, I think this one will be interesting. We can use a prefix, not prefix, we can use a, right, so this is the monotonic increasing stack solution. The number of, as we produce the monotonic increasing stack, we only keep track of the max value, right? Max value when popping happens, right? When popping happens, these max values mark the boundaries of the chunks, right? These max values mark the boundaries. We do not, right? We do not keep track of the mins, of the smaller values. Right? We only keep track of the max, right? Because if the smaller, it's fine. You will go through, but I keep the max. If the smaller, you'll go fine. But once all the smaller values has been exhausted, think of it this way. Think of it this way. Once all the values, right, smaller than the current max have been exhausted, no other value down the line can pop, right? Can pop the current max. Thus, current max, which marks the boundary, right, of the current chunk, will always sit in the monotonic increasing stack. So for this one, what I'm thinking, we have a stack, we have a mon, right? And we're gonna do it for a in array, if not mon, or hold a second. Usually what we do is we will check, right? And then if this, then we will pop. So usually we say while dot, and then if this is smaller than, right, if this is smaller than this, then we'll pop. Then we'll keep the maximum, so we'll pop, right? And if we have popped, then yeah, it's a bit complicated. Okay, so I just do this mon. This is smaller or equal to a, then mon dot append a, right? Else, then we say it's going to pop max, current max is going to be this and we say while mod and mod minus 1 is larger than a, mod.pop. And then at the end, we don't add a, we append current max. Ugh, redo. We append current max. Right. And at the end, we'll return length of the monotonic array. Need type annotation. This is going to be list of int. All right, let's see if this one works. Yep, looks solid. Oh, I didn't. Oh, okay. Solid. All right, the last solution is the max. So if the max so far is equal to the target max, it's too big, yeah, we have to wait if it's too small. So if it's equal to the target max, but we have an issue, right? We have this, the count issue. Oh my god, this is terrible, right? So if I do this 0, 0, 1, 1, 1, right? I know the target max. So I have 1, that's bad. 1, that's bad. And a 1, right? Current is 1. The max currently is 1. And this is a 1, so I count it. But that's no. But we need to do the count of the number of maximum. Right? It would probably need a counter of the number of maximum. So we just go this, and we'll count the number of times. If it's 1 time here, but here I already have 2 times of the max. Right? 2 times of the max. So it doesn't work. But here the maximum occurs 2 times. And then here the maximum occurs 2 times as well. And the max occur 2 times. What about the smaller values? Well, the smaller, so the smaller will have, but the makeup of the smaller values. Right? Yeah, I don't feel that is correct. Because let's say this is 2. Right? At this position, the max should have like that number of times. Okay? And for you, if the max does occur that number of times, because if it's only the one that's smaller, right? Because if I have something bigger, yeah, I think this one will work. Actually, we can try. We just need so this solution compares the sorted arrays max frequency with the unsorted, right? Unsorted arrays. Prefix max frequency. When the two matches, we have a chunk. So this is login, so I need to sort it. Right, sorted array, go to sorted array. Okay, what we need is, I know the max, but I need to know its count. So sorted count, okay. Pref max and pref max count. And the rest equal to 0. Oh my goodness, so many. So for IA enumerate array, okay, and if now pref max equal to max pref max A, right? If pref max is equal to sorted array I and sorted count. Sorted count plus equal 1 if I larger than 0 and sorted array I is not equal to sorted array I minus 1, then sorted count minus, right? Actually, if they're not equal, then this shall be 1. And prefix max. What about the prefix max count? If A is equal to prefix max, then prefix max count plus equal 1. Else too complicated. Not gonna do it because it's just we have better solutions, right? We have better solutions. So yeah, the 3 is good enough. I think the easiest one is prefix sum, pretty easy. A monotonic array requires some thought. Alright, anyway, that will be it for today. I'll see you guys tomorrow.